Hello, it's Professor Gifford here again, and today we are going to talk about elasticity and get the basic understanding of what is elasticity, how does it work, and what does it look like when you put it on a graph. And then I'm going to actually walk you through an example calculation on how to get the elasticity. So we're going to start here, and I'm sharing just a Word document with you to share some general points. Elasticity is basically just the movement that happens in relation to change in something else. So for instance, if we're talking about the price elasticity of demand, that means how does demand change relative to changes in price? If we're talking about the income elasticity of demand, now it means the change in demand based on the changes in income. So we're going to focus on the price elasticity of demand today, understanding that income elasticity would be similar. The difference would be the income elasticity is more going to have a reverse effect. For instance, if the price goes up, we know there's an inverse relationship. We talked about that last time. An inverse relationship for a demand curve. That means that as price goes up, the demand goes down. Well, with income, as the income goes up, the demand is going to increase with that. As people have more money, in other words, they're willing to spend more of it on certain things that they want anyway. So we look at these various elements. Now keep in mind that the basic demand for an object will be affecting that. So if they're looking at price elasticity of demand, it's how much of this do people want. And some products or services may have a sharp elasticity, meaning, hey, as people have more money, they definitely want more of this. A good example of that would be vacation and travel. As people have more money, they tend to spend it directly on travel, whereas as they have less money, they travel less, up until a point. So you would expect that. However, with, say, bread or milk, something that's a staple product, as people have more income, they're probably not going to go buy more bread and milk just because they have more money, assuming we're working with people who have the basic needs met. In fact, they might buy less bread and milk as they have more income because now they're going to focus more on eating out or enjoying those other luxuries. So you want to think about what factors are affecting this. And as we show this today, we're focused on price elasticity of demand, which does have that downward shaping curve that you're used to. And when you're going through these, always look at what am I being asked? Because remember, in economics, we break everything down specifically. So we're looking at one variable at a time. So in this case, we're looking at the demand curve. How does the demand curve, which is consistent across the board here, how does that change as the price changes? So I drew out some examples here for you. If you think about something that's purely inelastic, that means that no matter the price, the demand does not change. That curve would be directly vertical. That means, for instance, if we're here at a demand of 100 units, the price could be 0, we still want 100 units. The price could be $4 million, we still want 100 units. That would be something that's purely inelastic, meaning that no matter what, the demand does not change. Now, typically we look at these in smaller ranges. There would be a change in demand if we're looking at bread, for instance. At $0, we still eat the same amount of bread. Perhaps and up to maybe $5, even $10, we may still eat the same amount of bread if all other grocery prices were up, relatively speaking. The concept of substitutes and complements will be discussed in later sessions, but let's say all products go up equally. If bread goes up to $10, we may still want the same amount. But of course, if bread goes up to $4 million, demand would have to decrease because just not that many people have $4 million to spend on bread. So within reason, something is purely inelastic when no matter the price, the quantity that we demand does not change. On the flip side of that, something can be purely elastic, meaning we want exactly this price. So at this price, the demand could be as much as 0, or it could be all the way to whatever number could possibly be available. It wouldn't be infinity exactly, because there are a finite amount of people in the world and so much that each person could consume. So it's not exactly infinity, but it could go up until whatever. So we don't worry about measuring at extremes. In economics, we keep it within rational boundaries. So at something purely elastic, the price is irrelevant. It's really the demand that people want based on what's going on among other things, really. So that's purely elastic. It's going to be a fully horizontal shape. Most of the time in the real world, you're not going to see a whole lot of the purely inelastic or the purely elastic products. Typically, price will play a larger role in something than that. Now, you might see something that's, for instance, purely inelastic within a corporation. For instance, if they have a product that they develop and sell, then the price is not going to affect how much of something they buy if it's an input to that product. Assuming no other options are available, if, for instance, steel is the only way they can make this product and steel goes up or down in price, they're still going to buy that same amount of steel to produce what they're producing. So again, looking short term as what would affect. Of course, there are long-term effects, because now it affects their pricing in the market of the finished product, and that will affect the demand for the finished product, which may eventually, in the long run, affect our elasticity of demand. But we want to focus on the short term, keep it simple here. So purely inelastic is vertical, purely elastic is horizontal, and then we have elasticity slopes. I just want to explain something here, given some examples. Both of these curves listed on this graph are demand curves. One is an inelastic or more inelastic curve, and one is a more elastic curve. Now, if you ever forget or are not sure based on the curve, the simplest way to look at it is, well, if straight up and down is more inelastic and flat is elastic, the curve that is flatter, which you'll see here in the top curve, the flatter curve is more elastic. The steeper the slope, the more inelastic the curve. So these are pieces that are going to help you as you're going through the guiding principles when you're learning these in your courses. The flatter the slope, the more elastic. What that means is the flatter the slope, the more likely the demand is to change given a change in price. So let me give you an example of that here. I'm going to just make an assumption here. If I can come over here, and let's say that the price here is $10. So if we're dealing with a price of $10 at this level, then I think I can, yeah, so let's say this is $10 at this point. We want to look at $10, what's really going on? Well, at $10, if we just followed that dot along here, we would see we have a demand, and we're going to make some assumptions here. So that would give us this demand. Oh, did not want a line there. Let's try this again. At $10, we might have a demand that falls right about right here. So I'm just going to put a line across there so you can see the point. At $10 for the other curve, we have a different line, and actually that didn't carry out as far, but we'll see it'd be about right here. Let me go ahead and carry this line out for the example that we're doing here. Okay, so as we get $10, now here's what happens. Let's say we just drop a small amount. Let's say increase the price by $1. So we change the price by $1, so now we're here at 11. So we're going to mark our 11. Notice what happens. Try this one more time. So there's our $11. So now we're going to follow the same example and say, okay, that would bring us to here. And on the other curve, that's going to bring us to here. So you can see that we're just following the change in price. Now look what happens here. When we were at $10, our demand was right along this curve, about right here. When we go to $11, demand decreases, right? It's an inverse relationship, and it decreases. And I'm just wanting you to look at the spacing here. So this is about how much demand decreased. So you can see by the spacing, if this were drawn to scale, then that's the space that decreased, or the amount of units that decreased. However, we were here at $10 on the more elastic curve. And look where we end up on the demand. I don't like that curve. Let's do that one again. So we drop straight down and we end up about right here. Now, just measuring something that simple, you can quickly see, well, the demand clearly changed more on this flatter curve than it changed on the steeper curve for the same amount of change in price. Now notice we went straight across to get those points at $10 and at $11, and the number is really irrelevant. It's more about the shape of the curve. The movement was here. You'll see that the movement up and down on the curve is the same. So from here to here is the same height as from here to here. However, the movement horizontally was much bigger on this flatter curve because it just moved to a different spot before it intersected. So you will see then that something that is more elastic is going to have a small movement in the quantity demanded for a change in price. Given that same change in price, something that's more elastic will have a larger movement. So inelastic, small movement; elastic, large movement in the quantity demanded given any change in price. That's the basic principle behind and understanding the elasticity concept. Now let's move down here to understand the formula, because for many of you, you have to take this a step further than understanding, and you actually have to calculate it. Well, price elasticity of demand is simply calculated as the percent change in quantity divided by the percent change in price. Now, what does that mean for you? It means that ultimately you're taking the change in quantity. So that means how much did it change? In this example, we would put numerical points to these various pieces. So we would say the change in quantity simply means what was our quantity before and what is it now. And we just divide that by the base price, the price where we started. For percent change in price, we take the change in price, what was the price before and what is it now, and divide it by where we started with price. You'll notice both of these are basing that on what we were at each price level. So let's look at, for instance, an example here. If we were calculating total revenue here, the way you would do that would be simply to take the quantity demanded, which is the 140, and you would divide that by the $5. So you would have, in this case, a $700 total revenue. Not able to calculate your elasticity coefficients here. Why? Because there's nothing to measure from before. So the next one, we still have a total revenue of $700, but this time we can actually calculate that elasticity. Now I'm going to mark this out specifically so you can see exactly what would happen. So notice we're starting with a change in quantity. Well, what happened in quantity? We had 140, and now we have 100. So it's the difference. I'm actually going to write these out up here so we're going to say we started with 140, now we have 100. So that difference is 40. That's the change in quantity. It changed by 40. We divide that then by the price, and this, by the way, is the starting price, always the starting price. So the starting price we used was $5. And then for the next piece, we're going to say the change in price. So the change in price, it was 5, now it's 7. So that is a -2. And we're going to divide that also by that starting point for price, 5. So when we do this math, we take the 40 divided by the 5. And so what you'll notice here about that is it's very simple math at this point. So 40 divided by 5, 8. The second part of that is the -2. And you will always end up with a negative number when we're talking about elasticity of demand, especially price elasticity of demand, because they are inverse. So when there's an inverse, it's going to have a negative number. So you don't have to worry about that as much. So -2, you're going to divide that by 5. And what you're going to actually get by this one is the 0.4. It's a negative 0.4. So when we finish out this math, we take 8 divided by negative 0.4, and we just put it in on a calculator. You're going to get -20. -20. So you could easily put your elasticity coefficient here. Now this is pretty steep. That means it's very, very elastic. Remember, if something is 1, that means it's unaffected, inelastic. Something that's more than 1 is going to be very elastic. So the higher it goes over 1, the more elastic it is. So this one we would simply say is elastic. In fact, if you had measurements of it, you would say it's very elastic. By the time you get down to closer, let's say 11 to $5. So let's do this example one more time. Exact same thing. Now we're going to take the quantity we started with, the 45 minus the 25. Get that piece. We're going to divide that by the price where we started, again starting at 11. And we're going to take the 11 minus the 15 is -4, and divide that by 11. So now we're going to take these numbers. So your 20 divide by 11, you're just going to punch that in on a calculator. And it's okay if they don't come out perfectly. You can round. Always check with your current professor about how much rounding is necessary when you're doing this. Most of the time, 2 decimal places would be enough. If you're unsure, round out further. And if you're doing an online or an electronic process, such as some of the learning that do the Pearson has some learning modules where you enter it in on electronic and it's going to grade that. Actually read to see what it's going to grade. But most of the time, 2 to 3 decimal places will work. And again, you're going to take your 4 divided by your 11, and you're going to get -0.363. Would be 364, rounding up. So we're going to do the same thing, 1.818 divided by 0.364, and that's a negative. So it comes out to be, and this would go here, 4.99. And that's, again, a negative, which we would expect. There we go. And again, it's still elastic because the curve is elastic, so that's okay. It's still actually very elastic in this case. So you look for anything that drops under 1 would be your point where it's inelastic. So it's not changing compared to the price change. All right, so that's our example for today. Again, just running through the formula, doing the math, and that's going to get you to your results. And then you judge those results based on the numbers. Are they elastic, inelastic, and so forth. And again, you're just filling out, if you had an example like this, for instance, you would just want to continue this work and fill out all of the pieces. So you would want to take your 15 times your 25, and you would notice by the time we get to a price like $15, it seems wonderful, right? Okay, we're $15 we're getting per unit. but the problem is we're only making $25 per unit, so now it's $3.75. Just to help you further, and some of you will face some questions like this, if you were asked what's your optimal production point for this scale, you would just keep doing your math, and you would do this math until, and ignoring supply, just saying what would be the optimal point if we could ask for as much demand as we wanted. And if you kept doing this math, you would find out that 45 times 11, it's 495. So what we find at this level is the highest revenue point is either at $5 or $7 because they're both 700 in total revenue. So now we're going to look for where does the quantity supplied match the quantity demanded. And we would be looking for that because that has the best total revenue. Assuming there are any costs associated with this, then you may actually want to go with that $7 price because you're making the same amount of total revenue at $7, but you do not have to produce as many units to do that. And that's, again, other topics blended in, but just to help you see how all of this also works together. Okay, thanks for tuning in for the elasticity discussion. We will be back again talking about price ceilings, price floors, and other economics topics as they apply to you. Thanks and have a great day. Happy learning.